அவ்வளோதான் வந்துருச்சுதான். வந்துருச்சு. ஃபிலிப்பு தேங்க்ஸ் ஃபிலிப்பு. முடிச்சு. அலெக்ஸு. அவ்வளோதான்ண்ணா. 3 ஆயிடுச்சு. நீ அதுக்குள்ள போய் நைட் ஓகே ஃபிலிப்பு, நான் வந்து பண்ண நைட்.
ஜெகன், இப்போ நான் என்ன பண்ணணும்? Hello. Okay, hi. Welcome all. Good evening. Today we will be going to see electric vehicle. Okay, what is electric vehicle? Why we need electric vehicle? Google hi. Hi. Today we will be seeing about electric vehicle. Okay, history of EV. First, Henry Ford Moss is the one who introduced electric car at 18,000 period. Okay, is my voice is clear? Okay, during 18 period, the gasoline cost was $6.50. But the electric car, electricity bill was higher than the gasoline cost. In India, Mahindra electric car in 2001, they first launched the first EV car in 2001 in the name of REVA, which comes under Mahindra electric car. This is the REVA car in 2001, Mahindra EV introduced. These are the top 10 EVs at present. The top one is Tesla Model 3 and Audi e-tron, BMW i3, Renault Zoe, 2022 Ford Mustang Mach-E, 2022 Polestar 2. In Tesla, it takes about 30 minutes to charge from 10 to 80% in DC super fasting charging. In AC, it takes around 7 hours to charge. These are the drawbacks. These are the main drawbacks in EV. Okay, this is the charging station of EV. A charging station and a car, which will be plugged in. Okay. This is the growth of EV from 2010 to 21. You can clearly see the increase in multiples of the growth in EV comparing with the 2010 to the 2021. Comparing to 2021 and 2022, it is also increased. Okay, basically why EV? Why we need EV? EV is nothing about electric vehicle. It is mainly used to cut the cost down of alternative fuel. EV is also saving the climate. Compared to within 30 to 50 years, it will be less populated while comparing to the alternative fuel. Electric vehicles have very smaller carbon footprint than gasoline. Okay, basically how EV works. Electric cars function by plugging into a charging point and taking electricity from the grid. They store the electricity in a rechargeable batteries, and then it will power the motors, which is used to turn the wheels. Basically, EV are very light to drive compared to conventional fuel. We won't feel that throttling power and all. These are the basic comparison between electric vehicle and conventional fuel. In energy, electric vehicle is running by electricity. In conventional fuel, it is either by petrol or diesel. Next, coming to the factor pollution. In electric vehicle, it do not produce any powerful or harmful gases like carbon, and it contributes cleaner. In conventional fuel, it produces powerful carbon emission. And the next factor is running cost. Electric vehicle will be this is the average. In a fully charged battery, it will run up to 425 kilometers. In conventional fuel, for diesel, it will be 4 to 4.5 kilometer, and in petrol, it is about 6. And the limitations in electric vehicle are the charging station are very less compared to other countries. In India, the charging stations are very less. In conventional fuel, the fuel station are high, and the charging consumption will be in minutes. In EV, the charging consumption will be in hours. Okay, types of EV, there are basically 4 types: battery electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle, fuel cell electric vehicle. Battery, this is battery electric vehicle. It has battery packs and electric motor. Battery electric vehicle is also known as all electric vehicle. It run entirely on a battery powered. Electricity will be stored in a large battery which is used to run the electric vehicle. And the electricity can be applied to the motor and it will be used to rotate the wheels by the controller. The battery pack will be connected to one or 2 motors in the vehicle. This is hybrid electric vehicle, HEV. This is also known as series hybrid or parallel hybrid. It has both engine and electric motor. Engine gets from a fuel tank and the motor gets electricity from batteries. Transmission is rotated simultaneously by both engine and electric motor. Hybrid electric vehicle is nothing but it will be working in both engine and works both in fuel tank and battery. This is plug-in hybrid electric vehicle. This is also known as series hybrid. It has both engine and a motor. You can choose among the fuels such as petrol, which is conventional fuel, or alternative fuel like biodiesel. Battery can be charged externally. This is fuel cell electric vehicle, FCEV. This is also known as zero emission vehicle. They employed fuel cell technology to generate the electricity required to run the vehicle. Chemical energy is directly converted into electric energy. With the electric energy, it will be given to the power battery, and the battery is connected to the power controlling unit and electric motor. These are the EV components. Vehicle structure. In vehicle structure, we will be having wheel, vehicle body and gear. And PC is nothing about power control unit. In power control unit, battery, motor, onboard charger. Assembly means that wiper, lamp, flood lamp. This is inverter. Inverter is nothing about a conversion of DC to AC, and a motor for run the vehicle. This is the body, the transmission of the vehicle. Charging station. Charging station will be connected to the onboard charger, and the in battery bank, from the charging station to onboard charger, and the battery will be store the DC energy. This is the block diagram of EV. A charger, a battery, a controller, motor and wheels. Charger is connected to the battery. From battery, it will be given supplied to the motor. From controller, we can control the motor and the wheels. Okay, basically EV 80 to 90% in EV are power electronics. Power electronics is nothing about it deals with the design, control and conversion of power in the electrical form. A system which converts electric energy to an electric load through a control circuit is known as power electronics. It controls and converts electric power from one form into the another form. We will be discussing a lot about power electronics in EV in upcoming time. In EV, these are the sections where power electronics is used. Power supply. Inverter drive is one of the applications of power electronics. Onboard charger, a circuit will be in onboard charger, a charging station for regulating the current AC, how much it is getting. For that purpose, charging station, power electronics is used. Generally, there are power electronic switches. There are there like MOSFET, IGBT, SCR and thyristor. MOSFET is nothing about a metal oxide semiconductor field effect transistor. It has 3 terminals: gate, drain and source. IGBT is nothing about integrated gate bipolar transistor. SCR is a rectifier, silicon control rectifier and a thyristor. These are the basic waveforms. The first one is a AC waveform, sine wave, and the middle one is a triangular waveform, and the third one is a square wave. Okay, this is the sine wave, which is also known as AC wave. Okay, the top 0 to 1 is in positive region, and the bottom 180 to 360 it is in negative region. The sine wave is nothing about, it has positive and negative region. Okay, 0 to 360 degree, this is one cycle. For one cycle the time is 1 by 50. 1 by 50 is nothing about a T equal to 1 by frequency. Frequency is a standard frequency. For India, the standard frequency is 50. 1 divided by 50 is 20 milliseconds. In most of the country, the standard frequency is 50 only. From country to country, the frequency will be differ. It will be 50 or 60. In India, we will be having 50 frequency. Okay, this is DC wave. It has no negative off, it has only positive off. Okay, that is the question. Which is the most dangerous wave, AC or DC? Okay, can anybody comment in live chat? Okay, can anyone say the answer of which is more dangerous wave, AC or DC? Yeah, DC is the more dangerous wave because in sine wave it will be, in sine wave it will be getting into the negative region. It will be reaching 0 and it will be entering into the negative region. We have some seconds to remove our hand, or we can remove ourselves from the source. It will be about a fraction of seconds, like 0.05 like that. And DC we won't be getting that much time. Okay, can any of you say what is this waveform? This is AC or DC? Okay, this is DC because it has this is only positive region. It has no negative region. Okay, RMS, root mean square. Basically, we will be using this RMS in AC. In this waveform, we can easily rectify DC output. Okay, in this waveform we can easily Sai Kiran, it's not AC. AC mean we will be having a negative region. It has only positive of. Okay, in this DC wave we can easily find out the average value, but in sine wave it is not possible to find the average value. For finding the average value of AC, we are using this RMS. RMS is nothing about V peak divided by root 2. 1 by root 2 is nothing about 0.7071 into V peak. Generally, we will be saying the AC wave values in RMS value only. If we say 230 volt, mean we need to multiply with into root 2. Okay, this is PWM. PWM is nothing about pulse width modulation. This is used for controlling the gate pulses in the power electronic switches. And in PWM, the term duty cycle it is used most. The duty cycle is nothing about the time period of the cycle. If I say 50 duty cycle, mean it will be in 50% on and 50% off. If I say duty cycle 25%, mean 25% will be on and the remaining 75% will be off. If I say the duty cycle like 60%, mean 60% will be on and the remaining 40% will be off. Okay, this is 50% duty cycle, mean 50% on and the remaining 50% is off. 75 means 75 on and the remaining 25. And PWM will be mentioning the duty cycle in percentage value. Okay, in power electronics there are some basic converters application. These are the basics: rectifier, inverter, and DC to DC chopper. Rectifier is nothing about AC to DC conversion. Inverter is DC to AC conversion, and DC to DC chopper is these three will be used in the EV, but the inverter and the DC to DC chopper is used max. We will be seeing inverter, how to design an inverter, how to design a single phase inverter in Matlab. I will be see shortly. Okay, basically what is inverter? It is a conversion of DC form into AC form. The DC input voltage is controlled using semiconductors like MOSFET or IGBT. It has two types of inverter: single phase inverter and a three phase inverter. Okay, why EV need inverter? Electric vehicle is contain battery. In the battery only the electricity will be charged. Okay, and the battery is in the form of DC. For conversion of DC to AC, we will be using inverters. According to the EV, the motors will be differ. Some EV they will be using AC motors, or in some we will be using PMDC motor like PLDC motor. For the dashboard and the flood lamp, we will be needing AC supply. Single phase inverter is nothing about, it has 4 switches. So these are the switches: S1, S2, S3, S4, and a DC supply. And in between it will be connected to a load. When this S1 and S4 switches is on, the input will be DC and the output is AC. Okay, when the S1 and S4 switches is on, we will be getting positive. When the S3 and S2 switches on, we will be getting the negative region. Okay, when these switches were on, S1 and S4, we will be getting positive off. When the switches S3 and S2 are on, we will be getting negative region. Okay, we'll be seeing this in a Matlab. Okay, this is the Matlab. When you open the Matlab, you will be getting this one. Here, this is a Simulink. I figure we will be doing the single phase inverter simulation in simulation block. When you press the Simulink, you will be getting this dialog box. In this, create blank model. Already I opened. Okay, when you click that one, you will be getting this dialog box. In EV, most of the in EV powertronics, we will be designing design the circuits in Matlab simulation only. It is a heavy software. Before designing any circuits, save it and desktop. Okay, you cannot give any space. Try to don't give any space while saving the file. It won't accept in Matlab, it won't accept. You can see here, this is the library browser top. From here library browser, you will be getting all the equipments we need. Okay, go to Simscape. In Simscape, there will be electrical block. In electrical, go to specialized power system. In this only, we will be taking powertronics switches, DC voltage source and resistors. Okay, in powertronics, you can see the switches, MOSFET, diode, transistor, like that. Try to when you click MOSFET and right click, you can see add block to model inverter. Okay, or you can press Ctrl+I, it will be add to the model. And then I need a DC voltage source, it will be in sources. Okay, this is DC voltage source. And then I need a resistor. In resistor, we need to take series RLC branch. And then take a voltage measurement for measuring the values. And whenever you take any equipment from this control or any sources utilities, don't forget to take power give. Okay, without this the Matlab will be run. Okay, this is guys, is it, am I audible? Okay, we can by pressing the Ctrl+R, we can rotate the components. By pressing Ctrl and drag, we can copy and paste the component. I will be arranging like in the circuit diagram. Okay, in series RLC branch, double click. By double clicking, we can able to select resistor, inductor or capacitor. Okay, for now I need a resistor. Okay, and then in DC voltage source, connect it to the drain. Connect the negative to these sources. Okay, I need to, here you can see show measurement port. If I uncheck this one, the E will be removed. Okay, we don't need that E. Okay, E is for connecting to the scope and checking the MOSFET values. Okay, for the connect the source and drain. Okay, connect the resistor. Okay, in DC voltage source we can give the value as 24. Okay, this is the power give. For now I am removing this to show you what will be the error it will be coming, and I need a pulse generator. Pulse generator will be in sources. Okay, only this is pulse generator. By giving the pulse we can control the MOSFET switches. Okay, this is switch 1, this is switch 2, this is switch 3, this is switch 4. Okay, I will be renaming it. Switch 1, this is switch 2, this is switch 3, and then this is switch 4. Okay, I will be giving the pulse generator for all the switches. For now I am giving the pulse generator to switch 1. Amplitude is about 1, and the period is nothing about 1 by F. 1 by F it will be mentioned, should be mentioned in seconds, so I am giving the 40 equal to 1 by F. F is nothing about a frequency. Pulses you can give according to that pulse width. You will be controlling the on and off time. For now I will be giving 40, and then OK. For switch 1 and switch 4 it should be same only, so I will be connecting switch and switch 4 same pulse generator. Okay, for switch 2 and switch 3, drag, press control and drag, it will be copy and paste. We need to change the pulse paste delay. It is nothing about half of the period. Okay, 0.01. Okay, connect it. Now we need to see the value in values. For that I will be connecting the voltage measurement, and I need to take a scope block. It will be in sync. In scope we can see the output. Okay, connect it. When you press this is the time here. When you enter any time, it will be seen in seconds. Okay, when you press run, it won't be run. Okay, you will be getting a error block. This is because we removed the power give block. Okay, we removed this block. Okay, now you don't need to connect it, just place it there and now run. Here bottom you can see the compiling time. Okay, once it compiled, double click the scope. Okay, this is the scope. Here you can see the output of the design. I will be restoring the value, and in this zoom you can zoom x-axis and y-axis. Now I will be zooming x-axis. you can see the I given 24 as an input value. I was getting the output like plus 20 and minus 20. It won't be in perfect sine wave. For that only we will be there is a concept called multi-level inverter. To achieve the perfect sine wave, multi-level inverter that is used. I will be comparing the positive and the output to show the difference. Let me arrange this. Okay, you can by press here and you can combine the two scopes. I will be giving this to the input, see the voltage level and connecting it to the scope. Okay. Okay, now press the run button and you need to do some modification in the scope block, because now I entered two values. Here in this settings you go to the third and select 2. You can select horizontal or vertical. Okay, when you click you can see just restore the value. You can see the top one is input value and the bottom one is a negative. You can see a plain line. This is the input value 24 DC and the output we are getting, this is in AC. I will be changing the phase width like I was entering 70 to show you the difference how the single phase inverter works. And I change the pulse width. I will be giving 70 to all the switches and click on run. Now you can see the waveform is changed a little bit, like the on and off time is different. Before I given 40, now I changed it to 70. Okay, I will be showing you how pulse generator works in a I will be given the period as 1/50 and the pulse with the 70. Okay, now run it and see in the scope. Okay, here you can see it is on for 70 and off for 30. 70% it is on and 30% it is off. If I change it to 50, it will be 50 on, 50 off. Here you can see 50 on, 50 off. If I change it to 10, if I change the pulse width into 10, you can see for 10 it is on, for 90 it is off. Okay, this is the one cycle. For 10% it is on, for 90 it is off. If I give 90, if I give 90, for 90% it is on, and for 10% it is off. Okay, Srikanth ready? Now is it clear? Okay guys, we can wind up here. If you have any doubts, you can ask me in comment section. Or if I need to repeat this simulation for one more time, you can ask me, I will repeat it. Okay. Okay, you can go with SPWM method. So sinusoidal pulse with modulation. You can take it as a homework. Or you can try it by yourself. SPWM method. Because in real time we won't be using pulse generator. We will be comparing a sine and a triangular pulse. Okay, hope all of you understand. If you have any doubts or anything, you can ask me. Okay, black. Okay, sir. Okay, do you have any doubt, black? Do you need to repeat it one more time how single phase inverter work? Okay. Okay guys, see you. I will be winding up the class.